color change with any of these?
Let's check on it. We're gonna give them a couple minutes. See.
See gas coming out of the zinc and it's still bubbling.
Yes, so the zinc was, what color was it? It was like a gray metal. And with the addition of HCl, it's fizzing. Most of the solid is gone. Just a little piece in there and it is still bubbling. And I can hear it bubbling.
The whole solution kind of has that gray color now.
Mm-hmm.
Does anybody want to take a guess at what gas is coming off?
Zinc plus HCl.
Somebody nailed it. It's hydrogen gas being evolved, and you're making zinc chloride in the process. Actually, zinc dichloride, because it's ZnCO2, because zinc has a +2 charge. So, thank you for that.
Our magnesium is also mostly gone. A little bit of the strip is still there. It's still bubbling. I can hear it.
Same thing there, right? Hydrogen
Yes.
gas evolving, and then magnesium chloride being formed in the process.
The strip is mostly gone. All right. So that was magnesium. And then here's the copper, little copper colored pellets, and they're really not doing anything. They kind of bubbled at first for like a second.
Yeah, it's very quick.
And then it just stops. No color change and most of the solid is still there. All right, any questions for that part?
Is that the last part? Okay. We're gonna have to recap everything, because normally when I start the meetings on my device, iPad, phone, it'll record to the cloud, but this wasn't. So it doesn't have to be like you have to do it over, but just recap like each part at the end, and that way I'll have it on the recording.
Okay. So this one, part D2, is about reacting zinc with different acids of different concentrations. So all 9 of these test tubes have a little bit of zinc metal in them, and we're going to add phosphoric acid, hydrochloric acid, and sulfuric acid, all at 3 different concentrations. So I'm going to start with the phosphoric. I think that can put up before. That's not good. I see nothing.
Nothing's happening there. And that's what, how many?
That's 3 molar phosphoric acid, H3PO4.
Nothing really happened with this.
That's the case, and I don't really expect much to happen at the lower concentrations either. You know what I'm saying? Strongest acid they can do.
This is the 0.5 molar. Yeah, still nothing.
This is 0.01 molar. It's so narrow. Nothing.
So the zinc with all of the
Phosphoric acid.
phosphoric acid, we happened with either with the 5 molar, I'm sorry, the 3 molar, the 0.5 molar, or the 0.01 molar.
So that's it. Try HCl.
So first is 3 molar. So nothing happened.
How is that? Didn't we just get a reaction in the early part? Oh, well, the concentration's lower. So yeah. That's what makes the difference. I don't know.
So this is the 0.5 molar HCl. Nothing.
That's really cool too.
And then now for this 0.01 molar. Still. That was all for the HCl.
So here. Yeah.
Yeah. So this is 3 molar sulfuric acid.
Yeah, CHEM is doing solutions from last year.
3 molar. This is the 0.5 molar. Nothing happened. And then last for the 0.01 molar.
Which acid is this again?
Sure.
And nothing's happening there either.
It's a good design.
Yeah.
What's supposed to happen? Just observations.
Is this just an extra part of the lab? Like we don't have to write any data on this?
This is part D.
We don't have D2. We only have D1.
You don't have D2 either.
No.
Yeah, it's
Yeah,
okay.
it just stops
you can,
after the.
yeah, you can make a little table on the backside and just write it down that way.
Okay, so then, yeah, for D2, you can draw a table that's concentration, phosphoric acid, HCl, sulfuric acid, and then under concentration, we have 0.01, 0.5, and 3. And you just write your observations under each one, which would be really nothing. Because I don't see nothing more in here. It would seem these concentrations of acid are too low for a big noticeable reaction to take place. Because they're all just chilling. Not a single one is doing anything. Nothing. Oh, wait. Coming up. How's the light? Trick has gotten it.
There's a couple.
This is very small.
That's a hydrochloric
Very little.
or D2.
Mhm. No, there's.
Yeah, that would be hydrochloric.
Yeah.
So with the 3 moles of hydrochloric, we saw a very small reaction. A few bubbles were coming off.
So this reaction is going a lot slower than the other ones.
Again, probably because those concentrations aren't very high.
All right. CHEM is the one that dissociates the easiest. So I guess that would explain why.
That's the only one.
Yeah, all the other ones are like diprotic and tribrotic acids. This one, HCl only has the one H involved. So that would, yeah. Okay. I can repeat what I said about the table for D2, since you all don't have it. Or there's something in there? All right, let's move on to D3 then.
Y'all don't have the D3 one either, right?
Probably not. I
Yeah,
just put in the chat how to set up that table for D2. And what I can do is when I get back to my desk, I can cam scan that D2 and D3 in and just upload it to Blackboard. And you guys can fill it in that way and then turn it in. So for now, you can just collect the data and then you can fill in the handout after I upload it. I'll do it as soon as I get back to my desk.
So then the last part now, D3. We have 3 tubes with magnesium, Mg, another 3 with copper. What we're going to do is see how magnesium and copper react with the 3 different acids that we have. They're all going to have the same concentration, but they're 3 different acids. This is a 3 molar acid, the 3 molar hydrochloric acid, and the 3 molar phosphoric acid. All right, let's go. We're going. No, go back to T. I guess that's why. Now, okay. So phosphoric acid first. That's what the first thing is for?
Yeah.
Oh yeah, that is no worries. So phosphoric acid, magnesium. Ooh,
Quick one that happened immediately. It's already bubbling.
and again, this is a higher concentration, so that kind of makes more sense. Very strong reaction, bubbling, and the metals disappearing, and gases forming. Like this stuff. I like this stuff. Let's try that same acid, H3PO4, with copper.
What's the concentration of the acid again?
3 molar. They're all going to be 3 molar in this one.
Yeah, so nothing's happening with that copper. Yeah.
All right. We're down with phosphoric. I can still hear it.
So now we're gonna do the 3 molar of HCl with each of the two. So first the magnesium. Once again, immediate reaction. You can see that gas coming off, so that's a lot too. Yeah, that was pretty quick. So now with the copper. There's a few bubbles coming off, very tiny. Yeah, there's a few tiny bubbles coming off, but nothing super big is happening.
You can't see it. It's so slow. Is that it for the HCl?
And then so now this over here. Yeah, so now the sulfuric acid 3 molar. So first with the magnesium. Once again, immediate reaction. Yeah. The gas coming out. It's getting warm. All of those good things. The metal is pretty much already almost fully dissolved.
All the magnesium ones have gotten warm. They're all warm. And last,
The copper with the sulfuric acid. I'm not seeing anything with that copper.
right, so last part we tested how magnesium and copper react with 3 different acids of the same concentration. All the magnesium ones reacted very strongly with phosphoric acid, HCl, and sulfuric acid. They all got warm, they all started bubbling. The metal strip got smaller and smaller until it disappeared. Bubbles came off, and then for the copper one, pretty much nothing except for HCl. HCl gave us a little bit of bubbling, and that was it. And that is it. Sure.
Okay. What, any questions about the, before we recap?
No? Okay.
Nice work.
Thank you. That's work.
Oh, yeah.
So these are still in order. So the color, oh, you didn't add indicator for this one.
Oh, 1, 2, 3, 4, 5, 6. This is the order. Yeah.
Oh, this is, okay, I didn't know color.
Well, that was part of that.
Oh, it was the same. Okay, okay. So yeah.
HCl turned reddish.
This is just the initial part, that part A, am I right?
Yes,
It's different. Okay, go ahead.
Going through everything again. So part A, HCl turned red, nitric acid turned pinkish, ammonium chloride turned yellowish orange or light orange. Ammonia, that was the dark green one, right?
I think it was yellow. Yeah, this one, it kind of got touched by some other stuff, but it was, I'm pretty sure it was yellow. Yeah, it was yellow initially, but yeah, it's kind of funky now with colors, but it was yellow initially.
NaOH,
Is this?
green, in green. What's the last one? I don't even know. Well, that was the end. Yeah, we did initially. So is the last one? Is the last one? H3PO4. Yes.
And that's this magenta purple color,
Yeah.
H3PO4. Okay. And then, so then for B,
That was the end.
oh, we had the second one was the one for the indicator. How many drops? But Dr. Russell, you put the amount of drops from the indicator in the chat, right?
Yes.
Alright, so part B, the number of drops is in the chat. Part C, we were testing pHs again with iron chloride.
That's this purplish color.
I better just. C.
See, okay.
C, yeah. Okay. Sodium carbonate. Oh my, this one. Yeah.
No, they're in order here. So that's here. So this is the sodium carbonate. It's like a greenish color.
Sodium hydrogen carbonate. That was the last one we did. Was it
Yeah,
the yellow
this
one? No?
And that's like a yellow orangish color.
What's next?
So yeah, Na3PO4 is like this greenish color. Then that's
Which one is missing?
yeah. Okay, yeah. And that's like an orange, like a darkish orange color.
Which one was that dark orange?
The NaH2PO4.
Okay, thank you.
Yeah, because this one was. Yep. Okay. And so that was for part C. Yeah, this is just a rerun for the recording. If you already have the observations, that's fine. And then so D, Dr. Russell, did you get D on the recording or do we need to go back to those as well?
Yes, I have D with the
With the metals.
that's the part where you added to the metals. Yes, I have all of that.
Okay, cool. So yeah, so that's everything from the beginning of the lab.
Okay. And I think as those pH papers set and the oxygen in the air and the moisture in the air got to them, they probably changed a little bit. But if you have your initial observations, you should keep those. Don't change them. That was just for the purposes of going back through the experiment. Because I know sodium hydroxide was dark blue, because that should be really basic, right?
Yeah.
pH.
It definitely.
Whatever you wrote down initially, don't change it based on what we just did. That was just to make sure we had everything covered in the video. So when I upload it, you'll be able to know what happened.
Yeah.
Yep. All right. Is that it?
That's it. We're done.
Thank you. Anybody have any questions before we log out? No? Okay. Well, I appreciate you, Jay and Raven. Once again, another knockdown, drag out of the park lab. We appreciate it.
Thank you.
All right. Y'all take care. Have a good day.
You too. Bye, y'all.
If anybody else has questions, just email me.